So in today's class, we are once again going to be looking into Rhino, and we are going to dive a little bit more deeper into organic curves and surfaces when it comes to Rhino. So what we're going to be focusing on today is we're going to try and see what are all the different commands that is available in Rhino for creating an organic surface. This would kind of cover like the first half of today's session. And after we understand that, we are going to apply these commands and all the tools we have seen, including yesterday, to come up with a simple organic geometry. So these are the topics planned for today. So first, let me create a curve. I'm going to create a curve similar to yesterday. It's up to you. You can feel free to use the curve command and create a simple curve, or you can just rebuild a line and make it an organic curve. So that's up to you. However you want, you can create. I'm going to just start with a line, and I'm going to rebuild it with, let us say, 5 or maybe 8 control points. Whenever you're using the rebuild method, it's most likely because you do not have a specific curve in mind. You're just trying to have some interesting form created out of it. So don't have a really high number of control points. Stick to a set of control point which is less. If you have too many control points, it's going to be difficult to edit. What I mean by that is, let's maybe show you an example. I'm going to rebuild a curve of 5 control points and a degree 3. Let's have the same line, but this time rebuild it for maybe 25 control points. And now let's switch on the control points of it. If I try to edit the 5-degree curve, 5 control point curve, you can see it's very easy for me to manipulate into a simple smooth curve. In the case of higher number of control points, it's very, very tight. Like it's very difficult for me to edit this and get a really smooth profile out of it. So generally, I would suggest if you're using a rebuild method or you are even drafting a simple curve, try to stick with less number of control points. It just makes your editing process for the curve a lot more easier and smoother. So let's delete this. Let's consider this one. Maybe I'm just going to start with a new line. I have a different shape in my mind. I'm rebuilding it with about 8 control points. I'm just going to edit one specific point to achieve a shape like this. Maybe this one. And I want to create another curve. And for this curve, I'm just going to edit the control points a little bit different. Okay, so I have 2 curves that look something like this. I'm happy with how it looks in plan. I think it's quite organic. So I'm going to switch to 4 different viewports. Select this and zoom in all the 4 viewports. So I'm using the command ZSA enter, which is the short form of zoom select all. And I have the shape of the curve looking something like this. Now it looks quite interesting and organic in the top viewport, but when I look at it in perspective, it's quite flat. So this is the kind of curves we have seen yesterday. We saw how to rebuild a curve and edit it in one viewport. Today, what we are going to do is we are going to create or make the curve not planar anymore. When you work in a single viewport, the curve tends to be planar, like how it is right now. Planar as in lies on a flat plane. Or even if you take a look, all the control points of the curve, it is active only in the X and Y coordinate. Z coordinate of every single control point is 0. It's completely flat. So when I want to make it not planar, I just need to make sure all the control points are active in all 3 axes, that is X, Y, and Z. So I'm just going to pick a control point. When you're working on non-planar geometry, always work in all the 4 viewports. So you have a clear idea of how it is getting manipulated. Switching to the front viewport, editing only in the Z axis. Now it is important to remember to change only the Z, because if I edit the X axis, you can see plan gets deviated. I do a random move like this, still the plan gets very badly deviated. So don't do that. Make sure when you're editing the control points, you only use the gumball axis. And if it's to make the curve not planar, just change the third axis alone. Don't change any other axis in between. I'm going to repeat the same for this curve. I'm going to try moving 2 points here. And simultaneously take a look at perspective as well, how it's changing my geometry. Okay, so I think I'm okay with how the curve has been modified. Once I'm happy with the curves, that's it. You can just take a quick look out of it. Now, this is how you go about converting a planar curve to a 3D curve. You preferably start with a single viewport. You can choose what viewport you want to start with. Mostly it's going to be the top because you would end up knowing the plan of your geometry. And once you're done with the plan, switch to 4 viewports, edit the control points only in the z-axis, and you can make it completely organic. Now what I'm going to do is I want to create a surface between these two curves. Yesterday we saw a method of rebuilding to create an organic surface. Rebuilding is not a great method for creating organic surfaces when you're trying to be precise. The rebuilding method is something where you can just experiment with a surface, modify an existing organic surface a little bit more, or you can use it to kind of experiment some random forms and see where it takes you. Like it's more of an exploration command. Now, when you want to create something more precise, you would be starting with curves like how I'm doing right now. Using the curves, you will create a surface. In this case, I'm going to use a new command called as loft. Make a note of it in the command box. You can see the spelling, it's loft. Once I type the command and press enter, it'll ask me to select all the curves that is involved in loft. I'll just select these two, hit enter, hit OK in the dialog box for now. And if I change it to the shaded mode, you can see I have a surface that looks something like this. And again, for a better preview, just switch to the Arctic mode. You'll be able to see how the surface looks like. So again, select Z as enter, gives you a more zoomed in view. And you can just orbit it around and take a look like how the surface is being formed here. Now, let me show you the command loft once again. There are a lot of commands, but we'll just start off with loft for this example. So loft will work under a couple of criterias. First criteria is you need to have minimum 2 curves. If you just have one single curve, then loft is not the command to go for. Loft works for a minimum of 2 curves. Maximum number of curves doesn't matter. It can work with 20, 200, how many other curves are there? Loft can work perfectly fine. The minimum number alone is 2. The second criteria is to make sure all the curves involved in loft, they do not intersect anywhere. If they intersect, sometimes loft can get or give you kind of weird results. So it's always better to avoid any kind of intersection between the curves while you do the command loft. I repeat the criterias. You need to have minimum 2 curves, which we have here. Second is the curves involved or the curves you're going to use for loft. They should not be intersecting, which is also fine here. Once that is done, select them, type in the command loft, hit OK. We have a surface. Let us move the surface aside. Let this probably be our first iteration. We'll try manipulating the curves a little bit more. So I was saying about how the minimum for loft is 2, the maximum doesn't matter. So maybe we can start adding more curves here by manipulating it a little bit further. I'm going to create a copy of this curve. So I'm working in 4 viewports now. Again, observe how I'm shifting between single and 4 viewports. When I'm working on a planar curve, I'm working in a single viewport. The moment I wanted to edit in the third axis, I switched to 4 viewports. Again, after the curve editing was done, to create the surface, I worked in single viewport. Now back to 4 viewports because we're going to work on the next curve here. So I'm going to create a copy, working in 4 viewports, creating a copy in the top viewport, holding down to Alt and copying with the help of a gumball. Once I have the third curve, it's going to be the exact same. So look at it in all 3 viewports, it's the exact same. I'm just going to manipulate it a little bit. I'll try changing the height first. I think, yeah, something like this. So I'm changing the height along z-axis in perspective, sorry, in the front viewport. And the curve positions, maybe let's edit a little bit in plan. Simultaneously see how it's affecting the rest of your model as well if you want. Okay, so yeah, I think we'll try something like this. Okay, so even though it looks like it's intersecting in plan, look at it in perspective. Clearly, they do not intersect because of the height difference. So you need to be careful about that as well, that they do not intersect. And once you're happy with the curves, let's switch to the perspective. Let's use the command loft once again to create the surface. So tapping on the command loft, selecting the curves, enter, hit OK in the dialog box for now. You can see I have a surface like this. Now let's do one thing. Let's switch it to the Arctic mode and let's zoom in and compare both of the iterations. So again, in this set of curves that was there, loft, there are two criteria, which is minimum 2 curves. That's fine. We have more than that. We have about 3 curves here. And all the curves are not intersecting at any point, which means there is a higher possibility of getting a clean loft. Just type the command, hit OK. I have something like this. Let's just switch to the Arctic mode. Let's maybe zoom into this. I'm going to show you a new command here called as turntable. Turntable is just a visualization command. Helps you to rotate the model in 360 degrees to view all the sides of it. So rather than orbiting it little by little, this is a little bit more convenient. Command is turntable. You can control the speed of rotation in the slider. So this comes with the command. The moment you close the slider, the turntable stops. So let's try turntable again. I think the pace seems fine here. And yeah, so these are the 2 surfaces we have done. Now, there are a few more things in Loft that we can or you need to know. So let me move this aside as the second iteration. I told you 2 things about Loft where you need minimum 2 curves and the curves to be not intersecting. But there is also one more very important thing to consider while doing the Loft command, which is the sequence in which you select the curves while lofting plays a very important role on how the surface is being formed. So take this for example, and let us say I'm selecting the curves in the sequence of 1, 2, and 3. So the rightmost curve is the first one in the selection, middle is second, leftmost is the third. So when I use the loft command, I select in the sequence of 1, the second being the middle curve, third being the leftmost curve, and hit enter. I get the loft exactly same as how we saw before. Now, instead of that, if I change the sequence a little different, so for example, let's say first curve remains the same, second curve is the leftmost curve, and third curve is the middle one. So let's say I'm changing the sequence of selection for loft as annotated in green color. 1 is the rightmost, 2 is the leftmost, and 3 is the middle. Typing the command loft again, selecting 1, 2 being the leftmost, and third being in the center. Hit enter, hit OK. Look at how the surface is formed this time. Let me remove the annotation. And take a look at this. You can see the surface is very different from how it was before. So when I make the selection as 1, 2, and 3, basically how the surface gets formed is, it creates a surface between 1 and 2, and then it continues the surface to 3 like this. So this is how the sequence of the direction of the surface is being formed. So from 1, it goes to 2 and then to 3, something like this. So when you're selecting the curves, pay attention to how you're selecting, because the sequence of selection determines the flow of the surface direction. So from 1 to 2, it goes, then 2 to 3, it goes. If you had more curves, it will follow that as 4, as 5, so on and so forth like that. So make sure the sequence of selection is something you really pay attention to while you do the loft command. Any questions until this?
Yeah.
Yeah, hi.
Mhm.
You can go ahead.
Okay, thank you. Can we create a closed loft, like a completely closed curve?
You mean can we use a closed curve for lofting?
No. I meant like you show the order and how the order changes how the loft is used. So can like three be connected back to one? Like can it be a
Yep. So when you do a loft command, you have this closed loft option. If you switch that on, it gets connected back. If it's off, they do not connect like this.
okay? Thanks.
All right. Any other question?
If
Uh,
you don't mind, can you like repeat it? Repeat the loft command.
You
So
just need to
I-
have minimum two curves. Make sure they don't intersect, and then type the command loft. Select them in the sequence of how the surface should flow, and then hit enter. You get the
Okay.
surface.
Here you have mentioned that's a small number, so you have selected the curves, right? What happened? Hello, can you hear me?
Yep, I can.
Yeah, what happens there are what if there are many curves and if there's a particular order, it takes more time for selection, right?
Yeah, it will. So it becomes a little tedious when you have more curves. Ideally, you can select everything and try a loft. There'll be a default sequence the command itself follows. So right now I didn't select in a sequence, I just selected it together.
Okay.
Still, it worked pretty fine. So when you have multiple curves, try this selection. If it doesn't give you the kind of result you were looking for, then you have to mandatorily, select them one by one.
Okay. Thank you.
Welcome. I think there was another question as well.
yeah.
Yeah.
I just wanted to know what weird can happen if two of the curves are intersecting each other.
So if they are intersecting, you would get a self-intersecting surface. There are two kinds of intersection that's there. One is you can have them intersecting at the ends. If they're intersecting at the end, it's fine. So if they're intersecting at the end point, that's fine. You can just select and type the loft command and you will get something like this. So at the end is absolutely fine. But if it's not intersecting at the end, so let's say I'm rotating this and it's having some kind of, let me just, okay. So let's say it's having this kind of weird set of curves and I select them and do a loft and hit OK. You can see the kind of surface I'm getting is super weird. Like in reality, you will not be able to recreate this surface. You generally try and avoid something called as a self-intersecting surfaces. Self-intersecting surface is when the surface passes within itself and you have intersecting curves, then the chances of having that is higher. Like this.
All right, thank you.
Welcome. Any other questions? Okay, so let's do one thing. Let's see one more thing regarding loft that I haven't mentioned yet, which is regarding the lofting styles. So when I select and do a loft, loft gives you a dialog box where there are some interesting styles you can play around with. Default is normal, which is what we're getting right now. If I change the style to loose in the dialog box, you can see that the loft is created slightly loose from the curves in between. It does not follow perfectly the shape of the curves. The next is a tight one where it tightly follows that. You have straight sections where instead of having an organic cross section between the curves, it has a perfectly straight section. And uniform is again slightly different version of it. So you can kind of play around with the different styles like normal, loose, straight, etc. And also see what works the most interesting. And as mentioned earlier, you can also add this option of closed loft where it completely closes. So since it's a loose style, it's deviated from the original curve. If it was a different style, like maybe let's say tight, then it wouldn't be deviating. You would have something like this. So this way you can kind of play around with styles and some options in Loft. Whichever works best, hit OK, you get the result. And this way you can have a few iterations throughout and check around like what works the most interesting for you. Now, apart from Loft, the main thing I wanted to show you guys here was how to come up with 3D curves, because we will be seeing a set of surface commands. A few we have already seen, and a lot more like sweeps and network surface we haven't seen yet, where they input some organic curves and create a surface out of it. So you need to be a little bit more well versed on how to create these kind of organic 3D curves. As I showed you earlier, the easiest way to start with an organic curve or to create a 3D curve is to start as a simple planar curve in any one of the viewports. So for example, let us take a circle. You can take any curve. So I'm just showing you another option. So rather than rebuilding it or using a curve tool, I'm just going to take a pre-defined curve. So let's just take a simple straight circle. And what I'm going to do is I'm going to edit it. Circle has a degree too, so it will not give you a really smooth result. I'm just going to rebuild the circle before I edit it. So control points, I'm going to increase it to 12. For the shape I have in mind, an even number of control points higher than 8 will work pretty fine for me. I'm switching the degree to 3 because I want a smooth curve. Hit OK. I have something like this. Now I'm going to select the alternate control points. So now what's happening is when I'm editing, it's starting to become quite smooth. It's not having any sharp junctions. So I'm selecting the alternate control points. And once I have selected all the alternate control points, again, to have multiple selections, hold down to Shift in your keyboard while you're making that selection. And once I have selected all the alternate control points, I'm just going to scale it inwards. And when you scale it again, make sure you're holding down to Shift, because if you don't hold down to Shift, scales in one axis alone, giving an amoeba-like shape. When I hold down to Shift, it scales in all the axes, and I have the star kind of a shape. I think this looks pretty good to me. So I'm okay with how the 2D is. Let's switch to 4 viewports. ZSA, enter to zoom in and see how it is. So observe the workflow. We start with a curve in plan. We edit the curve to match the shape that works well for me. Once that is done, I'm switching to 4 viewport. It would be planar. I will select the control points I want to edit in the third axis, which is Z, and then edit the Z axis in the front viewport. The perspective is just for me to visualize how the final outcome looks like. That's it. And I have the 3D curve I was looking for. Once that is done, I'm going to try and create a surface here. I have a closed curve, so I can use the command that we learned yesterday, which is planarsrf. But when I type the command planarsrf, in spite of having a closed curve, it does not give me a surface. Any idea why this is happening?
Isn't it supposed to be on a planar surface on one of the two of the axes only and not the third?
Exactly. So when you're using the command planarsrf, apart from being a closed curve, the curve has to be on a single plane. Right now, it's not planar. You can see the curve is organic. It's active in all 3 axes. So planar surface won't work in spite of having a closed curve. When you have a closed curve that is not necessarily in the same plane, you can use this new command called as patch. Make a note of it. It's a new one. I'm using patch here because it just has a single curve. So if I had like minimum 2 curves, I would have considered using a loft. Since it is a single closed curve that is not planar, I'm going ahead with the command patch. Comes with this dialog box, hit OK for now. I'll have a surface like this. Again, let us switch to the Arctic mode and take a look. Looks something like this. I would prefer to isolate it. So when you isolate it, the ground shadows tend to be better. So I'm just going to select it, invert, and then hide. You can see this is the only thing in my screen. And that's it. So let's select ZS Center to zoom in and do a turntable if you want to have a 360-degree view of how it is coming up. So try until this. as I told you, the main idea is for you guys to familiarize on creating 3D curves. The command loft and patch, we would be seeing it once again as we go ahead with session along with all the other surface commands. But the main thing you need to familiarize is how to go about creating these 3D curves, because they are going to be the fundamental of coming up with any kind of surface that you're trying to do in Rhino. Any questions until this?
So, ma'am, over here now that it's a closed curve, so even but the curve, the edges are joined. That's it. There is no intersection in the center. So loft can be used over here also, right? Instead of patch.
You have only one curve. The first criteria of loft is minimum 2 curves.
Okay, okay. Oh, okay, understood.
All right. Answering the question from Param in chat, can you repeat the command patch? Just select the curve and type patch. That's it. And hit OK in the dialog box. Criteria is you need to make sure it's a closed curve. You can check that in the properties. And if it is not planar, also patch will work perfectly fine. It works on planar geometries as well. If it is not planar, then definitely go for patch instead of planar itself. It's about 6. Let's take 10 minutes for you to try this out, and then we will go ahead with the session. I'm just going to pause the recording. Meantime, any questions you can feel free to go ahead in the meantime.